hit record. And oh man, I hate all this stuff they stick on here. Expand it a little bit. None of this stuff is important for us, chapter 2, 3, or 6, this stuff?
Yeah, it's just extra problems I can do later.
Okay. So, we didn't quite finish number 4.
Yeah.
Did you get how and let's just maybe briefly talk about another way we could do this. I'm not sure it's worth. Related rates are the harder stuff, so if we're strapped for time, we probably don't want to spend that much time. So let's just do it the way we would do it. I think the fastest way. Okay. We solved for that. We solved yesterday for dr dt. Okay. What we want is dh dt. You with me?
Yep.
So I have to turn this r over here into an h. Well, I have a second equation that relates height equals a 3/8 of the diameter, which is 2 r's. So all I have to do is solve this for r. So r becomes 4/3 h. You with me?
Yep.
So now we have v equals 1/3 pi times 4/3 h squared times h. Well, we can combine those h's. So we have 1/3 pi. We do have to square the 4/3. That's 16/9. And the h squared and the h become h cubed. So now we have 16/27 pi h cubed. Now what?
Now you have
all the heavy lifting. Now you do the rest of it.
Now do you just plug in the 4 to the?
No, remember, there's always a step on these problems, these related rate problems, where you have to differentiate both sides. You have to do it implicitly. Usually you have to do it implicitly. But here's the thing. You would never have to even know explicit differentiation. Implicit differentiation works everywhere. In other words, what do I get if I implicitly differentiate this with respect to t? What do we get on the left side?
V dh dt.
Well, no. What's the derivative of v?
V prime.
1.
Oh,
so
yeah.
What I really get is 1 dv dt. Okay, don't need the 1. So what I'm left with on the left side is dv dt. So it's a lot like explicit differentiation. I could always use implicit differentiation. Always. Okay. Over here, I'm going to get 16/9 pi h squared. See how I got that?
Yeah.
Okay. Excuse me. Times dh dt.
Yeah.
So that is, once you get to this point, now we're trying to solve for this. and I can plug in for h and dv dt. They told us what dv dt was, 10. So 10 is equal to 16/9 pi, and h, what was that? H was 4/3.
No, H was just 4. Wait, no.
Yeah, no, you're right. Absolutely, you're right. 4 squared.
Yeah.
dh dt. Okay, so that, the final answer should be 90 divided by 16 squared, which is 256, equals dh dt. Now that can clearly be simplified. How far, I don't know. You can probably just turn that into a decimal with your calculator.
Yeah.
Remember, we got to multiply it by 100.
Yeah.
Because what we calculated was meters. So add 2 more zeros to that, and that should be the answer. 9,000 divided by 256.
Okay, I just don't have my calculator with me. It's in Texas.
Okay. All right. Well, like I said, we don't need the exact answer. We need the process. That's always the case with calculus. Let me take a look at this next problem here. That's cruel, to give your answers in centimeters per minute. I mean, it's not like the problem wasn't tough enough already. So number 5, how are we going to find the absolute minimums and maximums of the functions on the given interval? We'll start with that one. You cannot use your calculator, right?
Yeah, no calculator.
Graph it and find the maximum or minimum using your calculator. What's the calculus way to do it?
Isn't it just take the derivative?
Okay. So we know we have to figure out f prime. What's that equal to?
1 minus
So here's
x.
what we're looking at. We're looking at that.
Yeah. So it's negative, or x to the negative 1/2.
Okay. And we're still on the closed interval 0 to 9. Now what?
Now,
where do you find minimums and maximums?
isn't it?
What is the derivative when you're at a maximum? If I graph something like this, what is special about that?
Isn't that just where x equals 0?
Not x. F of x.
Oh, okay.
F prime of x is the slope of that line. And the most important concept of derivative calculus is all of your maximums and minimums are defined by a 0 slope of the tangent line. Doesn't matter what function you're looking at. I could be looking at just a parabola. Well, that point right there is where the first derivative is 0. And the point I'm looking for is this. I'm not so much interested in that. I'm interested in where on the x-axis does the maximum occur. So what should I do with this problem?
Set it equal to 0.
And then solve it. Okay, so in place of this, I'm going to write 0. go ahead and solve that. It might be a little easier to solve if I put it back into this format. Can you solve that?
Yeah, I'm just working on it. It's just 1.
Correct. Correct. X equal 1. Okay?
Yeah.
So what we know is that there is probably, it's not for certain, but that is either a minimum or a maximum. Okay?
Yeah.
How do we know which? What's the next thing we have to do to figure out whether it's a maximum or a minimum?
We do like a sign chart thing.
That's the first derivative test, and that's harder. There's actually an easier way to do it. Let me teach you that method.
Is it just the second derivative thing?
Second derivative. Because minimums are concave up. So if the second derivative is positive at x equal 1, then it's a minimum. If it's a maximum, it's going to look like that. It's concave down. Concave down is when the second derivative is negative. Now, the only time you have to really resort to the first derivative test, which is the line chart, is if your second derivative is not conclusive. In other words, if it's 0. If it's neither positive nor negative, then it doesn't tell you whether it's a minimum or a maximum, and you have to go back and you have to look at what the slopes are prior to the peak and after the peak. And if it goes positive slopes, the negative slopes, that's a maximum. If it's a minimum, then you're going to have positive slopes, you're going to go negative slopes to positive slopes. So that's the first derivative test to determine whether something's a maximum or a minimum. But the second derivative test is actually much faster, I think. That's the first derivative. So the first derivative is equal to that. Give me the second derivative.
It's just negative x raised to negative 3/2.
Got the sign wrong. It's the negatives are going to cancel, so you're going to have a positive x raised to the negative 3/2.
Okay.
And now the question is, what is that at x equal 1? In other words, you have to evaluate. In other words, I have to do f double prime of 1. And when I do f double prime of 1, I get a positive number. That means it is concave up, which means it is a minimum. Okay? Now, I think the second derivative test is a lot easier than the first derivative test. So it's worth knowing. However, if we go back and look at the problem, they said absolute minimum. Well, this little test that I used finds relative minimums. Now, it's true that between 0 and 9, there is only one place. However, we have to check the endpoints also. In other words, if I have a graph that looks like this, okay?
Yeah.
I do a first derivative, I'm going to find this spot right there, which is a relative minimum, but it's not an absolute minimum. Not between 0 and 9. between 0 and 9, that's lower. So,
Yeah.
and that can only occur at your endpoints. In other words, there's no way that if this was parentheses, then I would know this is the answer for sure, and it's a minimum. But the fact that it is brackets means I have to evaluate the function at the following places. I have to figure out what f of 0, and this is the real function. I have to figure out what f of 9 is. And I already know that f prime of 1 equals 0, which is a relative minimum. Now we have to figure out whether it is an absolute minimum or not. So the only things we have to check are these two to see if either one of them is, we also have to find the absolute maximum. And the absolute maximum, since we only found one spot between 0 and 9, and it was a minimum, then by definition, the maximum is going to occur at one of these endpoints. Or else it won't exist. Not everything has an absolute maximum. So we have to evaluate the function. So let's figure out what f of 0 is.
That's just, f of 0 is just 0.
Okay. So that's the same as the relative minimum. Now remember, the relative minimum occurred at x equal 1. But at x equals 1, no, the relative minimum, in other words, f prime, excuse me, it's f of 1, not f prime of 1 we have to evaluate. We have to evaluate these three things: f of 0, f of 1, and f of 9. We know that all three of those points on the x-axis could be key on the y-axis. Okay, we just figured out that f of 0 is 0. We now know, I just did the math on f of 1, and that is minus 1. And f of 9 would be 9 minus 2 square root of 9, 9 minus 6, so that's 3. So those are our key numbers that we figured out with all of this math. First derivative, second derivative, it came back to these three. So where's the absolute minimum?
Is it just at -1?
Well, that is the absolute. And they did say find the absolute minimum. Yeah. In other words, there's sometimes a problem in terminology here. Usually when they're looking for where the minimums or maximums occurs, they want their answer from the horizontal axis. They want their answer over here. In other words, the minimum occurs when x equals 1. But that's not the same as what the minimum is. The minimum is f of 1, and that was -1. So the absolute minimum was -1. The absolute maximum was 3 on those intervals. Okay, we're basically going to do the same thing for all of these, only the next one looks easier only because the derivatives are a lot easier. This is just a straight polynomial. Taking first and second derivatives should be a piece of cake. So let's start with, I'm going to do it over here because I don't think I need much room. So let's start with g prime of t.
It's 24t squared plus 162.
Excuse me. Yes. No, you're right. It is 62.
162 t minus 42.
Okay. Now, set that equal to 0. We'll find out where on the horizontal axis that we have zero slope tangent lines. Let me think of what's going to be the best way to factor that thing.
Would just be move the 42 over and then...
No.
Okay.
Remember, you're looking at a quadratic. If you're looking at a quadratic that's got a squared term, a non-squared term, and a constant, there is only one way to solve it, and that's by leaving everything on one side and putting 0 on the other. Well, we're trying to put 0 on the other anyway, because we want to know where the first derivative is equal to 0. So I'm going to set it equal to 0 and then solve it. But you don't put the 42 on that side, you won't be able to solve it. This is like all quadratics, you have to get, well, not like all. If there's no t term, then you can do it your way. But if there's a t term, it's impossible to solve by moving the 42 to the other side. What I want to do here, let's see, if I divide everything by 6, that will work. It gives me 4t squared plus 27t minus 7 equals 0. And let's just take a quick shot at factoring that. Still going to be hard to factor, but maybe not so much. Yeah, not going to factor that way. Let's try 4 and 1. I think this works. Yeah, it does. Minus plus 7 minus 1. That will produce that middle term of plus 27t. Because you have a 28t there, and you got minus 1t there.
Yep.
Okay, so the places where this occurs is 1/4 and -1/7. Now, our next step is to figure out whether they are minimums or maximums. How do I do that?
You take the second derivative.
G double prime of t is equal to what?
It's 48t plus 162.
Okay. And now what?
Now, don't you just plug them in?
Plug it into the second derivative.
Yeah.
In other words, at this point, we're trying to determine concavity. And when you're trying to determine, because concavity is what determines whether it's a minimum or a maximum. So yeah. I'm going to check these two. I'm going to figure out what g prime of 1/4 is. Is that and the only thing you have to do is figure out whether it's positive or negative.
Yeah, that's positive.
That makes it concave up, which makes it a minimum. And now let's check the other point.
And that's negative.
Is it?
Yeah, because 48.
I'm adding 162 to it.
Wait, why are you doing negative 1/7? That would just be 7.
No, when we factored it, we got 4.
It'd be 4t.
T minus 1 times t plus 7 is what we had.
Yeah.
Okay, that gives you a t of equal to 1/4 and a t equal minus 7. Ah, thank you. I did make a mistake.
Okay, I got really confused.
I'm sure you did. I apologize, Mitch. Last thing in the world a tutor ever wants to do is confuse his student. I definitely get confused when I do the wrong answers. Okay, and you're right. When I put the negative sign in there, it does make that greater than 172, so that's negative, makes it concave down, makes it a maximum. Step 1 done. Now, this interval, both of our numbers we came up with are in that interval, so we're safe there. So we've got two extrema in the interval, and I know which one's a minimum or maximum, but I don't know if it's an absolute minimum or a maximum. So I got to do what? I got to test 4 things.
Yeah.
What are they?
You have to test -8, -7.
What to write. Don't just say test it. Tell me what.
Oh, so you have to plug -8 into
Here's what
50.
I want. I want to test this. I want to test this. In other words, in the original function. Remember, we're looking for maximums and minimums in the original function. If you were looking at the graph, you could visually see it. But we have to test both of our inside points and the extremes. In other words, the outside of the interval. So we got to come up with those 4 numbers, and then we'll compare them with one another, and we'll know. In other words, the absolute minimum and maximum have to be in one of these 4 values. Okay? Probably not worth our time for me to do it on my calculator. That's not going to help you much. We can probably go to the next problem, C. I think in other words, I'm going to plug in 1/4 and I'm going to plug it into this function. I'm going to plug in -7 into that function. And I'm going to come up with a value. And then let's say I came up with 10, 9, 8, 7. Then I have an absolute maximum and I have an absolute minimum. If this number comes up to be 11, then that's the absolute maximum. It's not inside the interval, it's on one of the endpoints. So that's the process. All right?
Okay. Yeah.
And now we have trig. Okay, same exact problem. Let's start with h of theta, meaning that we're only going to find the variable theta on the other side. First step.
Take the derivative.
Go ahead.
It is 2 cosine theta minus 1.
Good. Next step.
Now it just plug it in.
No.
Or say equals 0.
Okay. Solve that. 2 cosine theta minus 1 equals 0.
Cosine 1/2.
Okay. Now, where does that occur in our interval? In other words, what's theta equal to?
Theta is...
That's a unit circle.
Yeah.
So there's going to be 2 places in the unit circle where cosine of theta is equal to a positive 1/2. First place, first quadrant. What's the angle?
Isn't it 3 pi over 2?
No, it's pi over 3. It's a 60-degree angle.
Oh, yeah.
Okay.
So that's not even in the interval.
What's the other one? Where else is cosine positive?
In the second?
Fourth. All students take calculus. all students take calculus means sine only in the second, tangent only in the third, cosine positive only in the fourth. All of them positive in the first.
Yeah, so
That's a useful thing to memorize is all students take calculus. So it's the fourth quadrant. And the equivalent of pi over 3 in the fourth quadrant is 5 pi over 3. It's 2 pi minus that. Okay? So those are 2 points in our interval where we know that either a minimum or a maximum is occurring. A relative. I should say we know that those 2 places we have an extrema. We don't know yet whether it's a relative or an absolute, but it's an extrema for sure. So what's the next step?
take the second derivative.
Okay. H double prime of theta is what?
Is it 2 negative sine theta? Or
Yeah, I'm just going to put the negative sign in front. Okay, and that's it. So now what's the next step?
now it's just plug the
So read
pi over
the next equation line.
so it's negative
Hold on.
2 sine.
When I say read it, here's what I'd like to hear. I'm going to take h double prime of pi over 3.
Okay.
And I'm going to take h double prime of 5 pi over 3. And I'm going to figure out, based on the second derivative, whether they're positive or negative. Is that positive? Pi over 3. What's the sign of pi over 3? It's positive, right?
Positive.
I'm
And then
multiplying it by a -2, so that's definitely negative. What's the sign of 5 pi over 3?
negative.
Times a negative, so that's going to be positive. Okay, so negative means concave down, which means maximum. Positive means concave up, which means minimum. Now, yeah, we still need to do the other tests. In other words, and what's the next thing I need to do to figure out absolute minimums and maximums on that whole interval?
You need to
4 things.
Do h is 0, and then
Okay, so we need h of 0. What else do we need?
and then h of pi over 2. And you need
Ooh, I just noticed something. I thought our interval was 2 pi. It's not. It's pi over 2, which means that is outside our interval.
Yeah.
So I didn't need that. My apologies again. So we're looking at a maximum only, and we don't know if it's an absolute maximum. So I got to check the 2 endpoints, and I got to check the point that we found in between the 2 endpoints. And I got to evaluate them at all of those. So let's just test your trig knowledge, which h of 0.
that's just 0.
What's h of 1/2?
Isn't it just
Start with what's the sine of 1/2?
sine of 1/2?
Excuse me, pi over 2.
Pi, yeah, pi
over 2.
Isn't it just
It's 1. It's 1.
Yeah, it's 1.
Okay. So what we have is 2 times 1 minus pi over 2. Okay, that's our answer. Pi
Yeah.
over 2 is what? What's half of pi? 1.6.
Yeah.
We have
Something.
2 minus 1.6, approximately 0.4. I'll put an approximate sign there. And finally, we got to analyze our point in the middle. So we have the sine, we have 2 times the sine of pi over 3, which is root 3 over 2, minus pi over 3. So if now we've got 2 times root 3 over 2 minus pi over 3. So we got root 3 minus pi divided by 3, which that's like 1, right?
Yeah.
And root 3 is 1.7, so 1.7 minus 1 is approximately 0.7. So that's all we need to know. Well, not really. I guess to answer the question, you'd have to have an exact answer here. In other words, I think, I'm not actually positive. I probably should look at the answers here and see if they're giving their answers as, in other words, in this case here, our absolute maximum comes at pi over 3, right?
Yeah.
And our absolute minimum comes at 0, one of the endpoints. So here's my question. Is their answer going to be 0 pi over 3, or is their answer going to be 0 and then approximately 0.7?
So they're doing, so the absolute minimum is 0, 0, and then the absolute maximum is pi over 3, and then root
0.7.
3, or no, it's root 3 minus.
So they're giving you both coordinates. Okay, that is the best way to do it. Yeah, for sure. Yeah, the minimum occurs when theta is 0 and it results in a 0 y. So if I'm graphing these, if I want to graph this thing, those points would be defined in terms of x and y. Yeah. So your first answer is that one paired with that one, or excuse me, that one paired with that 0. And the second answer is pi over 3 paired with the 0.7. It occurs when theta is pi over 3, but the absolute maximum is 0.7, or whatever that number is. I suppose what it is square root of 3 minus pi over 3, huh? Did they give it as a decimal, or did they give the answer as square root of 3 minus pi over 3?
Square root of 3 minus pi over 3.
Good for them. That's the only way to give the exact answer. Notice that that's irrational, that's irrational. So you have to express the answer in terms of stuff like that. Gee. Which brings up an interesting point. Imagine if I had a number like this. I don't know what caused me to think about this, but whoops. What would the answer be? That would be it.
Yeah.
In other words, any other answer but written exactly like this would be an approximation. Would not be an answer. It would be an approximation. All right. Take a picture. So they give us a first derivative. At which x does f have a local maximum or local minimum? And notice how they phrase this question. At which x? Completely different than the last question, which was where is the absolute maximum and absolute minimum? In this case, they don't want an xy coordinate. They want just where on the x-axis it occurs. Okay, so what's our first step?
Is it just set it equal to 0?
Yeah, because our locals have to occur at one of the places where the first derivatives of 0. The whole thing about a local maximum or minimum is it has a 0 slope tangent line at its peak or bottom. So what's the solution? What are my possible x locations? Where might this occur?
Is it just 1, 2, 3?
Hold on. Where's that equal to 0?
It's just
It's negative.
or -1, but then so just 2 -1s then.
Yes, you're absolutely right.
Okay.
In other words, it has a multiplicity of 2, but the 0 is at -1, not +1.
Yeah.
Okay. Now, what's our next step? To determine whether those are maximums or minimums. Now here, it might actually be easier to use the line chart. I think it probably will be.
Yeah.
Let's do the line chart, because the reason I say that is because this is not going to be easy to take the second derivative. To take the second derivative, I'm going to have to probably multiply those two together and then use the product rule, or else multiply them all together. It's going to be a hard second derivative to take. So the first derivative test probably is going to be the easiest one. And it's going to be relatively easy. Because all I have to do is figure out what the slopes are doing right and left of each of these points. So pick any number you want to the left of -1 and tell me whether you get a positive. Hold on. Yeah, this will work. We can use this on the first derivative function because this is the first derivative test. When you're doing a line chart, you're wanting to know what the slopes are to the left and to the right of these key points. Let's just pick a number to the left of -1.
-2.
Pick another number that's not a whole number. You see, excuse me, -2 was fine. I was thinking that turned that into 0. So, -2. -2, that becomes positive. -2, that's negative. -2, that's negative. Multiply all three of them together, what do you get?
A positive.
Okay. What that means is that the slopes of the original function leading up to -1 are positive. That's what we just proved. Now pick a number to the right of -1.
Is it just 0 or
That's when I say pick a number, I really mean pick the easiest number. And 0 is a very easy number here. That's plus, that's minus, still plus. Notice what that tells you about this point. The signs did not change left or right. Well, if you have a minimum or a maximum, they always change. That goes from plus to minus. If I have a minimum, it goes from minus to plus. Where in the world does it go plus to plus?
just at a
like that.
random point.
Well, not at a random point. First of all, we need a point that has a horizontal tangent line.
Yeah.
And plus, 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 plus. That is not an extrema. It's a horizontal tangent line, but it's not an extrema. And just be aware of all horizontal tangent lines are not extremas. And the beauty of this line chart here is it shows it to you exactly. The more we look at this, the more I'm thinking this could even be easier than the second derivative test. I'm not sure, but certainly on a function where it's hard to calculate the second derivative, this is a piece of cake. Okay, now let's look at 2. Pick a number to the left of 2.
2.5.
Yeah, pick a whole number.
Left of 2, but between 2 and 3, there is no whole numbers.
Left of 2. How about 1?
Oh, left of 2.
In other words, you always have to go left and right of each of your key numbers.
Okay.
Okay? Now, I'm pretty sure that left of 2 is going to be positive, because to the right of this was positive, and I've never seen it change signs in between these numbers. So I'm almost 100% sure that when I plug in 1 here, I'm going to have positives. Well, I am. That's positive, negative, negative. It's positive to the left of 2. Not sure I actually had to test that. I think the fact that those were positives ensure that those are going to be positives. Now, picking a number between 2 and 3, 2.5 is fine. 2.5, that's plus, but that's negative. So that's negative, negative, that's going to be negative 2. Picking a number to the right of 3, like 4, gives you positives. So our line chart tells the entire picture. Nothing is occurring there. What is occurring right there?
It's a concave down.
So what is that?
It's a maximum.
It's a minimum. Concave, nope, you're right. Sorry. Man, I made a lot of mistakes today. What's this point?
It's concave up.
Which makes it a minimum, yeah. Yeah, it's easy enough to remember positive goes with up and negative goes with down. What's a little tricky is that down means maximum and up means minimum. And that's why I can get confused because of that. Okay. So we finished 6, right? Totally?
Yeah.
That's good. I like the fact that they had 2 problems in a row here, where the first problem, second derivative was the best test. The second problem, the line chart was the best. That was 10 times easier than, first of all, even getting the second derivative. I'm not sure I've ever taken the second derivative where there's 3 products. You know what I'm saying? In other words, if f is equal to u times v times z, how do you take the derivative of that? I guess you multiply 2 of them together first using the product test, and then you take that product and multiply it by z using the product rule also. So it would definitely be a pain to take the derivative of that, which would be the second derivative. And that's great that they illustrate 2 problems where the easiest method is different in both cases. Okay, how do you determine if a function or where a function is increasing and where it's decreasing?
Isn't it pretty much the same thing we were just doing?
Little. Let's do at least one of them. Probably all we're going to have time for. Now we'll have time for more than one. So how do I determine where that function is increasing and where it's decreasing?
You just have to take you just have to take the derivative of it and then find the points where.
See, it's harder because you have to take the derivative of it and find out where it's positive and where it's negative.
Yeah.
Which is harder than setting it equal to 0 and finding out where the derivative is 0. In other words, here's our derivative. So where is that positive and where is it negative? Now, I can factor that, which you want to do, and I'll show you why. I do it right? Today I got to ask. Okay.
Yeah.
Now, wow. 60, what is 60? That doesn't even factor well. In other words, I got to figure out where that's greater than 0 and where it's less than 0. That's going to tell me where my function is, my original function is increasing or decreasing. The difficulty here is that's not easy to solve. And the way you solve products in an inequality, which is what this is with a line chart. But the first thing you need to do is figure out all your key numbers. What are your critical numbers? And the critical numbers are what makes that 0. So one of them is 0, and the other would be whatever you get. Am I missing something? I am missing something. Here we go. That is this. Now I need factors of 60 that subtract to the number 1. I don't have any. 6 and 10 don't. 7 and 8 don't. So I've got to use the quadratic formula to find the 2 critical numbers there. Doesn't seem like I should need to do that. Let me think about it. Maybe I'm not taking the easiest approach here. No, I am. I am thinking about something though here. So t equals -1 plus or minus the square root of 1 minus 4ac, which is plus 240, all divided by 2. So I hate it when they make you up. I didn't really want to erase that. I wanted that to stay up there. Let me rewrite it over here. Let's see, I factored, let's factor out a -20t squared. That makes it a little easier because then you end up with t squared plus t minus 60. It's not minus 60, it's minus 6, which is factorable.
Yeah.
Okay, so This is equal to minus 20t squared times t plus 3 times t minus 2. All of that has to be greater than or equal to 0. Now, do you know how to solve that? In other words, this is not a trivial inequality to solve. Think line chart.
Okay.
Now, what points on that line chart do I need to place?
0 or -3, 0, and 2.
Now we're going to do the same thing. Anything to the left of -3, plug it in there, and we'll see if it's positive or negative.
So it's -4.
Okay, -4 makes that negative. -4 makes that negative. -4 makes that negative. So it's negative everywhere to the left of -3. Decreasing from -infinity to -3, it's decreasing. Next.
-1.
Okay, -1, that stays negative. That becomes positive, that stays negative, so it's positive in this area. That means it's increasing because we're looking at the first derivative. In other words, that is a first derivative. Okay, and if I plug in 1, I get negative, positive, negative.
Yeah.
So it's increasing from -3 to 2. And if I plug in 2, I get a negative. Or rather 3, I get a negative. Because that's positive, and that's always negative. So it's decreasing. So I guess you have to give your answers in interval notation.
Let me look.
Here's what I think their answer is going to be in the book. It's decreasing from -infinity to -3 in union with 2 to positive infinity.
Yeah.
And it's increasing from -3 to 2.
Or they have it -3, comma 0, and then union with 0, comma 2.
Ah, it's true. Because it's not increasing at 0, is it? No, it's flat. Yeah, it's neither increasing nor decreasing. So just because I have 2 of them in a row there, I can't combine them. I'm glad we looked it up because that's a key point that I had not sure I've ever run into before. I'm sure I've made that mistake many times. Okay. Good. All right, so we've made it through number 6. We've made it through 6. Problem is each one of these has 3 questions to it. So we've actually probably done 15 problems. Let's see, how far is it? How many questions are there? I'm just trying to judge how long it's going to take us to get through 17. Okay, probably another 4 sessions.
Okay.
I'm guessing because it took us 2 sessions to get through 6 problems. Should take us 6 sessions to get through 18 problems, which would mean we need 4 more sessions. Just guessing, and that might not be correct because these are bound to get more difficult the further we go. So far they've been relatively easy, but I can see some questions here that might be harder, especially, nah, maybe not. L'Hopital's rule is actually really easy. No, I'm not sure they do necessarily. Newton's method is definitely a little tricky, but not that much. Once you understand Newton's method, it's just hard to remember because you use it so seldom. That's the problem with Newton's method. But I understand it. I can certainly help you with that. So we're probably looking at 4 more sessions to do a good job of this.
Okay.
Okay? All right, Mitch. We'll let you go, and you're welcome to schedule whenever you find a spot. You know, if you have like a morning and you're wanting a session and you don't see availability, call me or text me or something. Because,
Okay.
like I said, my son is visiting, and I've blocked off some time just to spend more time with him. But I don't mind. Sunday I could not do it. That's the only day I really can't do one.
Yeah, I fly out Sunday and I have to work a bit, so.
Okay. But next week you can see I got all my mornings available.
Okay.
All right?
Yeah, I'll probably do like Tuesday at like 10.
Sounds good.
All right.
Talk to you later.
All right, thank you. Bye.